Okay, so we have sort of one last piece of problem solving that we need to go over in the last few videos here on this last chapter. And that has to do with heat. You know, we talked about boiling in the last chapter and vapor pressure. And so that allows us to connect some calculations with boiling and also freezing and melting with heat and calorimetry. So remember, a while ago, we did problems with calorimetry, right? And so I want to remind you how to do this. We're just going to do a practice problem here. If 1 gram of water is heated from room temperature, 20 degrees C, to 80 degrees C, and you're given the specific heat of water, how much heat is required to do that? So remember, we use Q equals MC delta T, where Q is the heat that we're calculating for, M is the mass, C is the heat capacity, and delta T is the change in temperature. So this is going to turn out to be, right, mass is 1 gram, that's given to us. C is also given to us, that's 4.184 joules per gram centigrade. And then the change in temperature was 80 degrees minus 20 degrees C. And so it's just going to be 60 times 4.184 times 1 gram, right? And so that is equal to 251, and our units are going to be joules. And I guess with sig figs, we would call that 250, or really this only had 1 sig fig. Let's add a sig fig to it, okay? So 250 joules. So that's just a reminder of how to do these types of problems. Q equals MC delta T. Good. Now we can get into the next video, some more complicated problems. But first, let's go over some concepts that will lead us there, okay? And so the first is this idea of what's called a phase diagram. And, you know, now that we explained how boiling point changes depending upon pressure, right? Because vapor pressure changes depending upon temperature, right? And so temperature that something boils at depends upon pressure. And so you can come up with these curves of basically temperature versus pressure and what state of matter. Is it a solid? Is it a liquid? Is it a gas? Okay. And so if you're going between solid and liquid, we know that's melting and freezing. If we're going between liquid and gas, that's vaporization or condensation. And you can go from solid to gas, like dry ice does that. That would be subliming, or going the other way is called deposition from gas to solid. A weird point here exists where actually you are going in between solid, liquid, and gas simultaneously. That's called the triple point. So it's boiling, melting, and subliming all at once. And it's depositing, condensing, and freezing. That point exists for all substances. There's also something called the critical point. This is where liquid and gas start to become indistinguishable. You have this like gas-liquid hybrid. That's the best way to describe it, okay? It's sort of like a different state of matter. It's called a supercritical fluid. And don't worry too much about it, but it's pretty cool. All right, so here's a phase diagram of water, just something that we're familiar with. Here you can see is a solid liquid line. And at 1 atmosphere of pressure, right, that is occurring at 0 degrees C. That's the melting point of ice, right, or freezing point of ice. And then also at 1 atmosphere of pressure, there's the normal boiling point of 100 degrees C. Then there's some other weird things that can go on, right? You can see that there's actually a point where once you're above 374 degrees centigrade, okay, and above 218 approximately atmospheres, you're in a supercritical fluid. You're in a gas-liquid hybrid. It's just a weird state of matter. Okay, it's because you added so much pressure basically to the gas, but it's so hot that it wants to be a gas and it wants to be a liquid, so it ends up being something that's like both, okay? And then there's also this triple point here. CO2 is a different one. CO2, remember, that's dry ice when it's solid, and we said that sublimes. And so if you look at 1 atmosphere, look where you are. You're right here At 1 atmosphere, you're going to go right to solid and to gas. So that's going to be sublime, telling you you're subliming. There's also supercritical CO2, same type of thing. You can look at this really interesting YouTube video where they got it at the triple point of cyclohexane, which is normally a liquid at room temperature and pressure, but it's pretty crazy. It's boiling, subliming, freezing. It's boiling and freezing at the same time. It's melting at the same time as it's condensing. It's doing all those things, interconverting between solid, liquid, and gas. It's at equilibrium. All of those 3 stages at the same time, which is it's pretty wild. But there is a point for every substance, every pure substance at least, called the triple point, where it's in equilibrium between solid, liquid, and gas.